So getting back to establishing identities, sometimes it's hard to tell which side is the more complicated side. When I look at this, I've got cosecant of theta minus cotangent of theta on one side, and I've got sine of theta over 1 plus cosine theta on the other side. So when I'm working through this, you can choose which side you want to work with. I think in this particular case, I'm going to work with the right side. And I am going to simplify by multiplying by a conjugate. I'm going to take the right side of this problem and I'm going to multiply by 1 minus cosine theta on both the top and the bottom. So I've got this problem where I've now got sine of theta times 1 minus sine of theta times the cosine of theta. I went ahead and multiplied that out. And 1 plus cosine times 1 minus cosine, remember, is 1 minus cosine squared. Trig identity, I can replace that. Sine of theta minus sine of theta cosine theta over sine squared theta. I don't know if you remember in the last video, I showed you that if there's a single denominator without any pluses or minuses, we can split that into two fractions. Sine of theta over sine squared theta minus sine of theta cosine theta over sine squared theta. These signs divide, they cancel out, leaving me 1 over sine theta. These signs cancel out, leaving me cosine over sine theta. Well, what is 1 over sine theta? 1 over sine theta is cosecant, keeping my end in mind, and cosine over sine theta is tangent, and it's minus. And so the first side is identical to my end. My first side is identical to my end, and therefore, cosecant theta minus cotangent theta is equal to sine of theta over 1 plus cosine theta. We have established that that is always an identity. This next problem down here, let's take a look at it and see how we're going to approach it. I'm probably going to work with the left side. I know that I could rewrite this in many ways, but I think I'm going to work with the left side here and just see if I can do some simplifying by first of all turning everything into some version of sine or cosine. So I'm going to have sine squared theta minus sine theta over cosine theta, because tangent is sine over cosine, over cosine squared theta minus cosine over sine. So I'm going to work this as two separate pieces. I'm going to work with the top first, and then I'm going to work with the bottom. I'm going to make it one great big problem, but I'm going to work with the top part first. I want to turn this into one fraction. I'm going to turn this into a fraction where I've got sine squared theta times cosine of theta minus sine of theta over cosine theta. Common denominator, right? I multiplied this by, this was over 1, I multiplied the top and the bottom, and I put them all together into one problem. I'm going to do the same thing here, making cosine squared theta sine theta minus cosine theta over sine theta. Okay, still looks more complicated. But now, what if I told you I want to factor out a sine theta of both of these and a cosine theta from both of these? Let's rewrite it. Sine of theta times sine theta cosine theta minus 1 over cosine theta over cosine theta times cosine theta sine theta minus 1 over sine theta. Okay, I've got multiply top and bottom by cosine, multiply top and bottom by sine. Why would I do that? That makes this cancel. That makes cosine cancel. That makes this term cancel. And I'm left with sine times sine. So that's sine squared theta over cosine times cosine, which is cosine squared theta. And that is equal to tangent squared theta, because sine over cosine is tangent. We have proven that the left side equals the right side, and so we have established an identity. This looks a little messy in the middle, so let's go back and take a look at that one more time. Don't forget, once we had reached this point, I could factor out a sine of theta, leaving me a polynomial here. And from this one, I could factor out a cosine of theta, leaving me the same polynomial, because sine cosine is the same as cosine sine. They're both minus 1. This allowed me to eliminate my denominators. I multiplied by the common denominator, and I was left then with sine times sine over cosine times cosine, which is sine squared over cosine squared equals tangent squared. Let's take a look at this next problem. I'm going to work with the right side of the problem, and I'm going to multiply by a conjugate. So I'm going to use this one with conjugates. Multiply the top and the bottom by 1 minus sine of theta. On top, that leaves me 1 minus sine squared theta. You should be getting used to that pattern by now. 1 plus sine times 1 minus sine is 1 minus sine squared theta over cosine times 1 minus sine theta. Now, why didn't I distribute this out? Because I noticed over on the left, remember, keeping the end in mind, I'm probably going to want that 1 minus sine theta later, so I'm not going to multiply it out yet. What is 1 minus sine squared theta? What is that an example of? Well, that's a Pythagorean identity. Remember, that is worth cosine squared theta over cosine theta times 1 minus sine theta. The cosine squared, the cosines, the single cosine will cancel out, leaving me cosine of theta over 1 minus sine theta, and it's now identical to the left side. I'm just bringing this down so you can see them next to each other. The two sides are identical, and we've established the identity. Let's do one more. I'm going to work with the left side, and I'm going to split this into two fractions. Cosecant of theta over sine of theta minus sine of theta over sine of theta. Well, cosecant is 1 over sine over sine of theta minus 1. If I multiply both the numerator and the denominator, I will get 1 over sine squared theta minus 1. Well, what's 1 over sine squared theta? That is cosecant squared theta minus 1. That's an identity. That's cotangent squared theta. And we have proven that the two sides, I'm bringing this down, the two sides are equal to one another. And therefore we establish the identity that this left side is equal to the right side of the problem.